All right, welcome back. I hope you're having an awesome time so far. Our next speaker is Hyun Kim. He is the CEO at SuperbAI. Please join me in welcoming Hyun to our virtual stage.
All right. Hi, everyone. My name is Hyun Kim, founder and CEO of SuperbAI. For those of you who don't know, SuperbAI provides a B2B SaaS platform called the SuperbAI Suite to help machine learning engineers, data scientists, and project managers label and manage machine learning training data more efficiently. Today, I want to talk about some of the challenges that you may encounter when building computer vision models, especially when preparing the training data. And then I will introduce to you how our platform, the SuperbAI Suite, can help you automate and accelerate your data preparation pipeline by using several advanced machine learning techniques. To start things off, I want to briefly go over the major stages of a computer vision data preparation pipeline. The first step to creating your training dataset is collecting the raw data, such as images and videos, and this is also called data ingestion. Sometimes you might be crawling the web, and sometimes you might be having many edge device cameras deployed on site, streaming videos and images to your cloud servers. In any case, after these images and videos are collected, you want to review, validate, and load them into a downstream data platform system, like the SuperbAI Suite, that is designed to help you create and manage large-scale training datasets. Once you finish collecting and ingesting raw data into your system, the next step is data labeling and auditing. I'm sure most of you are already familiar with this step. Typically, this is done by a team of project managers and labelers internally, or sometimes outsourced to labeling agencies or crowdsourced workers using services like the Amazon Mechanical Turk. Companies tend to rely on in-house teams for data that require domain knowledge, such as in medical or manufacturing applications, or for privacy-sensitive data. Otherwise, it is common that teams outsource to outside data labeling agencies. So once you have a labeled dataset, you then want to audit your dataset on such as whether your labels are accurate enough, whether your dataset size is big enough, or whether the distribution of your data is well balanced across all the cases and scenarios that you want your machine learning model to learn about. And the third and the final step to data preparation is data delivery. When everything is labeled and audited, you then deliver the dataset to a team of machine learning researchers and engineers who can use the data to train a model. The preparation pipeline doesn't end here because they will probably come back to you requesting you for more data or make any changes to your dataset. So the preparation pipeline repeats over and over again. Now that being said, let's take a look at some typical bottlenecks within the computer vision data preparation pipelines. We spoke with hundreds of data and machine learning engineers, and the pain points were all very similar, if not the same. The single most common pain point of these teams was that they spend 50 to 70% of their time on data preparation and management, instead of spending more time on training the machine learning model itself. In other words, data labeling and auditing takes too much time and money for these teams. To begin with, data labeling itself takes a very long time because almost always it's a brute force manual labor job. And after you're done labeling, if you find any problems within your data sets during the auditing phase, such as your labels are not accurate or your data set distribution is skewed, then you need to go back to data labeling or even go back to the first step of data collection and ingestion to fix these problems. And interestingly enough, based on our surveys and interviews, data labeling and auditing was the major bottleneck for both teams that are just starting a new computer vision project, as well as more mature teams with machine learning models well in production. For both types of teams, everyone knows that repetitive manual work is not very efficient, and everyone wants to utilize machine learning somehow to automate the manual data labeling and auditing process, but it's easier said than done. Let's talk about the case for companies and teams that are in the early stages of machine learning development. These teams want to utilize AI in some way, but the problem is that they don't have any models trained on the kinds of niche data sets that they are working on, nor can they find any open source data sets that are designed for their domain specific use case. As such, they don't have any pre-trained models that can be used to automate data preparation. And so they inevitably have to resort to manually collecting, labeling, auditing datasets from scratch. Now let's take a look at the situation for more mature ML teams that are well into their machine learning development and deployment lifecycle. These teams tend to have a very sophisticated trained models and are focused on identifying the cases where their model fails. They want to prepare additional datasets that can be used to improve their model's accuracy on these edge cases. And they are also focused on addressing issues like data drift, which is when the accuracy of their trained model degrades over time as the characteristics of the data upon which their model is trained changes over time. This could be due to some kind of seasonality of their data or other outside environmental factors. In any case, they have a constant need to find where their model fails, collect more of these edge cases, manually label them, and deliver them to machine learning engineering teams. So you can see that in both cases, regardless of what stage of the machine learning development lifecycle you're in, there's a constant need for manual data labeling and auditing, and it's difficult for teams to automate this by themselves. Just to get a better sense of just how much it takes for ML teams to create a training dataset, let's do a quick back of the envelope calculations here. Typically, when you're first starting your computer vision data preparation, you want to start at around 100,000 images. Let's also assume that these images have 10 objects per image on average. And from our experience, it takes usually around 2 to 5 seconds to draw a bounding box annotation for each of these objects. That means you're looking at spending more than 1,000 man-hours on just data labeling, this very first training dataset. If you add in the time to audit and validate the labels, you'll be spending considerably more time and money than this. In addition, let's say your project gains momentum. You have a successful POC, and you now want to deploy a model that you can, now you want to develop a model that you can deploy in a real-world environment. As your project progresses, you will have to constantly collect and label more and more data to improve your model's performance. And when you rely on brute force manual labeling, the cost to label increases linearly proportional to the number of labels that you create. And what makes things even worse is that you'll need exponentially more data and spend exponentially more money as your model performance improves. As you can see on this graph on the right, your model's performance will plateau as you add more and more data. To put it in another way, the marginal gain of your data diminishes as your model's performance improves. So let's say it takes you 50,000 or more images to 50,000 more labeled images to improve your model's accuracy from, say, 85% to 90%. If you want to improve your model performance from 90% to, say, 95%, you probably need to provide the model multiple times more data and thus spend multiple times more money than you did before. Well, despite all these challenges, luckily there are a few ways that you can leverage AI assistance to help you label data more efficiently and help you cut cost and time. One of these ways is embedding AI into your labeling tool. For example, there are interactive AI labeling tools that takes, and for example, a bounding box annotation that a human labeler manually draws and converts it into a polygon segmentation. Another popular method is called model-assisted labeling. This is where teams that already have a pre-trained machine learning model can upload the model's predictions or the model's outputs and use them as a starting point for the labels, also called pre-labels. So how this works is after the model predictions are uploaded, the labeling team can review and verify the model outputs and make changes if they find any errors. This kind of model-assisted labeling is good for labeling what your model is already good at detecting. For example, if your model is already able to detect cars or persons in images, it can be used to further label images that contain cars and persons. But here's the catch. In order to improve your model's performance, you want to focus on collecting and labeling the edge cases where your model accuracy actually fails. You won't be able to improve your model performance if you keep feeding it data that it already performs well on. So by definition, model-assisted labeling will not work well for labeling these edge cases, which is usually the most valuable piece of your training data set. Also, if you do try to use pre-trained models on these edge cases, you'll end up spending more time fixing the model predictions called the pre-labels than just labeling these edge cases from scratch. Now that we've looked at the bottlenecks within computer vision data preparation pipelines, let's take a look at what makes the data preparation for retail especially difficult. First of all, the images and videos that computer vision models need to process in retail applications can be especially dense. And what I mean by dense is, as shown in this image right here, the images can have a lot of objects. So this makes manual labeling for retail data very difficult and expensive. Sometimes these images have hundreds of objects per image. For example, this image you see on the slide contains 430 bounding boxes. The next challenge is that the images we see in retail applications tend to vary a lot in terms of the viewpoint, the camera angle, and the lighting conditions. This means if you take a pre-trained model that is trained on open source datasets like the COCO dataset and try to use it to help you automate data labeling in retail, your model will likely not perform very well on these rare viewpoints or lighting conditions. The third challenge is that in order to train your model to be able to detect rare events, such as theft, fire, accidents, or violence, you will need to collect and label images of these rare events. A good analogy is that if you want your self-driving car to drive well during rain and snow, you will need to train your car on images of such events because deep learning models learn from what they see during training. So trying to collect these rare events itself can be a huge challenge. But what's more is labeling these rare images with a pre-trained model is almost impossible when you don't have enough of these rare events to successfully train a model to begin with a catch-22 type of situation. Despite all these challenges that makes it difficult to automate data labeling in retail, I still think there are ways in which it can and it should, in fact, be automated. Now I'd like to introduce a few ways in which my company, SuperbAI, is using advanced auto-labeling techniques to help industries, including retail, automate the data preparation pipeline. One of the techniques that we use is transfer learning. Transfer learning is when you have a pre-trained model and you reuse and repurpose it by retraining it on a new set of data. For example, if you have a model that is trained to detect cars, you can retrain it on images of bottles, cans, and plastic packets to recognize objects for retail applications. So within the platform that we provide for our clients, called the SuperbAI Suite, we have a very large pre-trained model that can be repurposed by training it on the data that a user provides. This significantly reduces the amount of data and amount of time it takes to obtain a trained model that can be used to automate your own data labeling pipeline. The second technique that we use is called Viewshot learning. Viewshot learning is when a model is trained on a very small number of training data. So instead of having to label tens and hundreds of thousands of images, you can instead label just a few hundred images and then use our platform to create a custom model that is tailored to your dataset and immediately use it for data labeling. The third technique that we provide within our platform is automated machine learning, also known as autoML. AutoML is a technique to automate the process of training and testing machine learning models. So instead of having your machine learning engineers spend hours trying to train a model and fine-tune the hyperparameters, our model will do just that for you without any human intervention, custom engineering work. It only takes one click to train a fully customized model on your data. The fourth and final technique that we use within our platform is uncertainty estimation. Based on Bayesian deep learning techniques, uncertainty estimation is basically enabling a model to output predictions as well as how sure or unsure it is with its own predictions. So this is a very critical component to automated data labeling that often gets left out. Since your model's accuracy will not be 100%, you will always need some human reviewer to find and edit any errors by the model. And when you do that, uncertainty estimation allows you to quickly narrow down images that you need to review. You want to focus on reviewing images that your model was unsure about instead of reviewing every single image or randomly sampled set of images. So uncertainty estimation helps our users automate the data auditing or the QA/QCing phase of the data pipeline. Instead of manually reviewing every single image, we let our users focus on the small number of errors in the model output that actually need human review. So if you combine all four techniques, here's what you get. Using transfer learning, you can retrain and repurpose our pre-trained models based on your data. And using Viewshot learning, you can do this with a very small number of your data, as few as just a few hundred images, instead of having to prepare and label tens and hundreds of thousands of images. Third, using AutoML, you can do this without any human intervention or any custom engineering work from both our side and your side. And finally, using our uncertainty estimation, you can audit data much faster by focusing on reviewing labels that the model was unsure about. So all in all, what that means to you is that you just need to have a few hundred labeled images, and only after a few clicks and about 1 hour later, you can access a trained machine learning model that is tailored to your data that can be immediately used to automate your data labeling and auditing. And finally, I'd like to leave you off with what I think the ML-first approach to data labeling and auditing should look like. This is our recommended way to delivering high-quality data sets in just a fraction of the time. So if you're just starting out a new computer vision project, here's what I suggest. After you ingest all the raw data you collected into a data platform, so this could be data that you collected from the web, from edge devices, or crowdsourced. After you do that, you firstly should label just a few hundred images manually. And for this step, you can do this by yourself. You can outsource to a labeling agency, or you can use an internal data labeling and management team. After that, you can train a customized auto labeling model on our platform in just under 1 hour without any engineering work. It just takes a few clicks. When that's done, you can then apply trained model on the remainder of your data set to instantly label them. And along with the model predictions, our model will also tell you which images we think you need to audit. And again, this is based on our uncertainty estimation framework, which uses Bayesian deep learning methods. And finally, when you're done auditing these small number of hard examples, you're ready to deliver the training data to your machine learning team. Once that's done, your machine learning team is able to train a model and possibly get back to you requesting for more data or make changes to your training data set. Now, when you think you have a model that is somewhat well-performing and you want to improve its performance, what we suggest you do is, after you gather a new set of raw images that you want to augment to your existing data set, you first run them through your pre-trained model and upload the model's predictions to our platform. So you would end up here. Then we will help you find the cases where your model fails on. And after you relabel some of these failure cases or the edge cases, you can then train our auto labeling model on the edge cases. And after that, you can then use our auto labeling model to further label and audit your edge case data. The cycle repeats over and over again. And on each iteration of your model, performance will improve, and you will slowly cover all the different types of edge cases that you want your models to learn about. So this is SuperbAI's ML-first approach to data labeling. And this is also the way I recommend every ML team to adopt going forward. ML teams need to have the ability to rapidly create and deliver high-quality datasets. And the only way to do this is by leveraging these advanced machine learning techniques to automate your data preparation workflow from data ingestion, labeling, auditing to delivery. If you have any further questions on our ML-first approach to data labeling, please feel free to contact us. Thank you very much for listening.
Awesome. Thank you so much, Hyun. That was amazing. And we really appreciate you sharing your insights with us. And we know the audience is giving you a big virtual round of applause. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and check out our amazing AI exhibits. Thanks so much, and we'll see you around.